Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I'm going to discuss about thermal properties of matter, which is class 11th chapter of physics. Okay, so I have already given here how many topics we are going to discuss. So basically, we will discuss about temperature. Again, after that, relation between different types of scale, ideal gas equation, and absolute temperature. So these are the topic where I will focus. So thermal properties of metal. Therm means what? You try to understand before going to deeper. We need to understand why we are studying about thermal properties of nature. See here, therm means what? Heat. Study related to heat is known as therm. So the properties of matter, according to the heat, according to the temperature, we are going to study this in the details. Okay. So as you know that as we add energy on something, for example, this is a matter, and if we add heat, what will happen? Its temperature rises, and as we remove the heat, then what will happen? Temperature will decrease. So why this is happening? So we all will discuss one by one. Okay. So first of all, I am going to discuss about temperature. What is actually a temperature is? Okay, so it is defined as the degree of hotness or coldness of a body, and heat will flow from high temperature to lower temperature. So it is the temperature is the degree of hotness or coldness. So basic, if I will talk about basic things, so you need to consider, suppose there is a matter. Okay, so matter in any matter there is an atom is moving. Okay, so it has a molecular movement. So if it is moving, that it has some energy. Yes. Now suppose I'm taking another matter, and it has also molecules and atom, and it is moving very fast, right? So it has velocity. Suppose velocity of the molecule is here 10 meter per second. So here we will consider this as a 50 meter per second. Now, if velocity is 10 meter per second and it has velocity of the molecule as a 50 meter per second, so can we tell that the energy at A or B which has greater? So definitely energy at B is greater than energy at A, because molecular movement is high. So as it is seen that when we measure the temperature, the more molecular movement is there, so more it has energy and more it has a temperature. So we have introduced some scales so that we can measure the degree, this type of degree. So it is defined as the degree of hotness or coldness of a body. Why I am talking about hotness or coldness? Because as soon as it start moving, so heat is being there. So whenever we give energy, so what in the form of heat, so what happen? Its molecular movement increases. So heat will flow from high temperature to lower temperature. One very basic and important thing is that anything will always flow from high to low level. If you talk about water, so water will flow from high to low level only. We cannot see anywhere that water is automatically flow from low to high. Similarly, heat is also flowing from high level to low level. So heat is flowing from high level to low level, right? So these are the form. Okay. So I hope you have understood now temperature. I will also discuss about the scales, right? Now let us consider thermal equilibrium. Equilibrium means balance condition, okay? So two body is said to be in a thermal equilibrium with each other when no heat will flow from one body to another. What do you mean by this? So let us consider there is a body like this, and another body, there is another body also like this, okay? So its velocity is 10 meter per second. Whose velocity? Velocity inside its molecule, and it has 10 meter per second also, same velocity. So if you measure, then the thermal temperature or temperature of the both the body will be same. So if we connect the body, so what will happen? If we connect the body, so the temperature will remain same. No heat is flowing from one object to another object. Why? Because temperature is same, degree of hotness or coldness is same. For example, if we are taking a tumbler, okay, and it has a full of water, and another tumbler or buckets are there, it has same level of water. So can you tell me that there is a flow of water? Yes or no? Yes or no? Never, because it has same level. In spite of very high level, also it has same level. So at a same level, no flow is happens. Okay. So in this case, what happens actually? Heat flows from high temperature to low temperature. But as soon as in thermal equilibrium condition, no heat flows are happening. Why? Because both have same temperature. So two bodies are said to be in a thermal equilibrium with each other when no heat will flow from one body to another body. So I hope you have now understood the concept of thermal equilibrium. If a body, let us consider if a body one has a temperature 10 degrees Celsius and another body has a temperature of 20 degrees Celsius, so definitely heat will flow from high to low. But if the temperature of both the body will be same, so it will be in a thermal equilibrium. It is like a pressure equilibrium. Okay, so if pressure of one object is 10 pascal and pressure of another object is also 10 pascal, so no mechanical movement you will able to see. Okay, mechanical movement means what? See here, try to understand. Let us consider there is a piston and cylinder process. So this is your piston, right? This is your piston, and if you see, this is a piston and there is a gas inside this piston. Okay, so if there is a lots of gas inside this piston, so what will happen? If a pressure at inside is your 10 pascal and pressure outside is also 10 pascal, so no movement either outside or inside is going on. If pressure difference will be there, if inside pressure is 20 pascal and outside is 10 pascal, so piston will move outward and reverse will be same. So what happened? There is a pressure difference at all. There is a pressure difference at all. Got it? So it is defined as the degree of C here. So I hope you have understood. So this is your mechanical equilibrium. This is your mechanical equilibrium. Mechanical equilibrium. Similarly, if we talk about thermal equilibrium, temperature will remain same. So temperature is here as well as here, both have the same. So there will be no transfer of heat at all. Got it? Now I will go for heat. I will discuss about the heat. So basically, what is heat? So most of the time we heard that heat is the form of heat is the energy. Okay. So one thing you must remember, that if you are telling that this body has heat of 1000 joule, so it is wrong to say. Okay. It has no heat. Heat is a flow phenomena. Heat is flow phenomena. Flow phenomenon, right? Transient phenomena. Whenever there is a temperature difference, whenever temperature T1, that is T high temperature, and T lower temperature happens, then heat will flow from high temperature to low temperature. But we can't say that there is a heat in this body. There is a heat in this body. Heat is the result of, as a result of a temperature difference. It may flow from high temperature to low temperature. Okay. Now let us see what we have written. Heat is a form of energy transfer between two or more systems or system and surrounding by virtue of a temperature difference, and SI unit of heat is joule. See, system and one system to another system, one system to another system. Let us consider. Let us consider there is a one system, it is called system A, and there is another system, it is known as system B. So if system A has a high temperature and system B has a low temperature, it may be 30 degrees Celsius, and it may be high temperature is equal to 100 degrees Celsius. And when we contact this both body, so what will happen? When we make contact with this body, so what will happen? Heat will flow from A to B, and this is your transient phenomena, means flow phenomena. It is your flow phenomena. It is your flow phenomenon, right? So there is a temperature difference. So whenever there is a temperature difference, So it flow from a system to another system. One more case is that suppose there is a system and it has a temperature of 100 degrees Celsius, and after that system, rest of the part of the universe is known as surrounding. See here, system and surrounding you should know. System and surrounding you should know. See here, let us consider this is the confined area where our focus has been made, and this is known as system. This is known as system. Then the outside this system, what will be the outside this system? It is known as surrounding. It is known as surrounding, right? So if surrounding temperature is, suppose normal temperature we have in atmosphere is 25 degrees Celsius. So if 25 degrees Celsius is your surrounding temperature and inside system temperature is your 100 degrees, so what will happen? Temperature will flow from 100 degree to surrounding. So that's why heat is a form of energy transfer between two or more systems or system and surrounding by the virtue of temperature difference, and SI unit of his heat is joule. So if you talk about SI unit, so it has a SI unit of joule, right? Now the SI unit of temperature is degree Celsius. So if you want to find the SI unit of temperature, so it is a degree Celsius. So you have understood the difference between temperature and heat. Heat is the flow phenomena and it is the form of energy. But what is temperature? Temperature is not an energy. It is showing you the parameter, reading, right? So pressure you are telling Pascal. What is Pascal? It shows the how much pressure it is. Same thing, temperature shows you the temperature is a parameter which measures the degree of hotness as well as coldness, right? So I hope you have understood this both phenomena, right? Now, I have written here NTP normal. What is NTP and NTP, STP? So NTP means what? NTP means normal temperature pressure. Normal temperature and pressure. What is STP? It is the same thing. Both have same meaning. Standard temperature and pressure. Okay, so normal temperature pressure or standard temperature pressure, and it is equal to 273.15 Kelvin. It is equal to 273.15 Kelvin. And the pressure whenever I am talking about that please the given condition is your STP or NTP, that is standard temperature pressure and normal temperature pressure. It means that I am telling you that the temperature is equal to 273.15 Kelvin and the pressure we are talking about is 1 bar. So to measure the temperature we require an scale. So there are three types of scale. So as you know that how to measure, because it is a parameter, so we need to define it. So how you will measure any type of scale? So you need three types of scale. So one is your Celsius scale. It is also a standard unit, okay, SI unit, right, of the temperature measurement. And another is your Fahrenheit scale, and third one is your Kelvin scale. So to construct a scale temperature, two fixed points are taken. See here, to measure, to construct the temperature scale, so there are two fixed point has been taken. One of the most important is your first freezing point, that is the temperature at which any body, or the condition at which any body freezes or any water gets freezes. And boiling point, another parameter which is known as boiling point of water. So boiling, it is the upper fixed point. So two fixed point we have done, right? See, if I am talking about water, so water has two fixed point. We have done two fixed point. Okay, so this is the line where we have told that water will freeze at this point and water will boil. That is, it will convert into gas form at this point. Now, and whatever you want to see here, this is your Kelvin scale, this is your Celsius scale, and this is your Fahrenheit scale. So all three scale has been subdivided into different part. Okay, different scientists or different assumption has been made. But the thing is that all the three thermometer have same boiling point and same freezing point. it may happens that the value may be different. For example, value at a freezing point is 0 for degree Celsius, and for Kelvin it is your 273.15, and Fahrenheit it is your 32. And similarly, boiling point of water at for a Kelvin is your 373.15, 100 for degree Celsius, and 212 for what? 212 for Fahrenheit. Okay, so two range of a Kelvin this has been taken. Celsius is 0 to 100, and Fahrenheit from 32 to 212. Okay, now further every scale has divided its own parameter, own division. They have done own division. Okay, but one most common thing for all of is that both have a same boiling point and same freezing point. I'm talking about the label. I'm not talking about the values, right? I'm not talking about the values. So I hope you have understood now. Now using this, we need to find a relation. So how you will find a relation? See here, the relation. How you will find relation? For example, if I'm talking about temperature of Celsius is Tc, and it has maximum temperature 100. Again, temperature in Fahrenheit degree Celsius is Tf, or F we can say, and the Kelvin is your K temperature. Okay, so how you will find relation? How you will find relation? So first of all, if you I am talking about Kelvin, so K you should be if you want to find K, so put here K minus lower limit, that is freezing point. How much Kelvin has freezing point? That is equal to 270. It will be 270. 273.15 divided by upper degree, that is boiling point, and minus freezing point, that is equal to 270. It is your 273.15 minus, sorry, it will be 373. Highest minus lowest. We should always subtract it from highest to lowest. Okay, so let us do this. So highest is your 373.15 minus lowest is your 273.15, and this is equal to if you talk about Fahrenheit, so take degree Celsius, so take temperature in degree Celsius minus what is the lower part, 0 degree Celsius, divided by highest minus lowest. Highest is your 100 minus 0. Similarly, this will be equal to similar fashion you have to take Fahrenheit minus lowest temperature is lowest freezing point is your 32 divided by boiling point minus freezing point, that is equal to 212 minus 32. So these equations are used to interconvert all the thing. So same thing, but what you have observed, the ratio we are taking will be same. Subtraction of the for example, water boiling point minus freezing point of all the temperature scale will be same, right? So these are the important relation where you need to memorize it, so that you will able to convert any temperature to other temperature. So if you want to convert temperature in degree Celsius to temperature in Fahrenheit, use this relation. If you want to find a relation between temperature Fahrenheit to Kelvin, so use this relation. If you want to find degree Celsius to Kelvin, so just use this relation. Okay, so I hope you have understood now. Use this relation. So if above relation can also be rewritten as temperature at degree Celsius divided by 100 is equal to temperature at Fahrenheit minus 32, this will be divided by 180, and this is equal to K minus 273 divided by 100. So if you talk about this part A and this part and this part, so we will get T temperature in degree Celsius divided by 100 is equal to K minus 273 divided by 100. So 100 got cancelled. So temperature in degree Celsius is equal to Kelvin minus 273. So if you have a Kelvin temperature as equal to 373, so what you will put here? 373 minus 273, that is equal to 100 degrees Celsius. So it means that if you have a Kelvin temperature as a 373, so use this equation, so you will get temperature in degrees Celsius. The value of temperature in degrees Celsius is same as that of a 373 Kelvin, right? So these are the interconvertible. So you need to use this formula, right? Whenever you get a time, so try to use this formula so that you can able to convert 1 degree Celsius to Fahrenheit. So let us consider temperature in degree Celsius divided by 100. This is equal to temperature in Fahrenheit minus 32 divided by 180. So 2 9 ja 2 5 ja. So this will be temperature in degree Celsius is equal to 5 by 9 into Fahrenheit temperature, that is F minus 32. So by using this relation, this is not minus at all. So 5 by 9, so temperature in degree Celsius is equal to 5 by 9 in Fahrenheit minus 32. So if you have a Fahrenheit as a 212, so what you will do? So use this so that you will get temperature in degree Celsius. Okay. So these are the thing, these are the formula where you will able to use this. Okay. Now let us consider ideal gas equation. Okay. So before ideal gas, if you am talking about ideal student, means it what assume as the best student. Okay, which follows all the rules. Then only we consider that the students are ideal gas. So suppose there is a gas container containing a gas molecule. Okay, see here. So I will make you understand what is ideal gas equation. Before that, you need to understand that suppose there is a jar. Okay, and jar has a gas G container molecules. So any gas will be represented by the minimum 3 characteristics. So it has 3 characteristics. For example, now the position or state, I am talking about first state. So in first state, it has a pressure P1, it has a volume V1, and it has a temperature T1, right? Right? So these are the pressure P1, V1 volume, and T1 temperature. So by using these characteristics, we can tell that what is the actual state of the gas. So for state of a gas, you need 3 characteristics to represent any gas. What type of situation that gas is in. Okay, what is the pressure, what is the volume, what is the temperature at all. Now I am talking about state 1. So state 1, it has pressure, initial pressure V1, initial volume V1, and initial temperature T1. Now as we heat, so what will happen, this will gain energy and it will try to expand. There may be happens that there is an increase in a pressure. So we don't know, we are not aware about this. So we are not aware about it. So suppose let us consider there is a state 2. So at state 2, pressure will be P2, volume will be V2, and temperature will be T2. So these are the final pressure, final volume, and final temperature. Okay. Now, from the above condition and experiment, it has been seen that pressure is inversely proportional to the volume if temperature is constant. So I will make you this understand from the basic piston and cylinder. So let us consider. This is your piston and cylinder, right? So this is your piston and cylinder system. Okay, so there is a gas, right? There is a gas, and see here, when we apply a heat, suppose when we apply a heat, so it has a pressure P1 and volume V1 before applying a heat. So when we apply a heat, we saw that temperature is constant. Temperature is constant. If temperature is constant, in spite of being heat is there, so what is happening here? What is happening here? If temperature is constant, then what will happen? Let us make you in another way. I will make you try to make you understand. See here, temperature remain constant. Suppose there is a piston cylinder things. Piston and cylinder are like this, okay, and there is a gas like this, okay. There is a gas like this, okay. Now let us tell me if somehow volume will increase, then what will happen? Pressure inside the gas will reduce. But the thing is that temperature should remain constant. So this is what it has given, that pressure is inversely proportional to volume when temperature remains constant. And this is given by Boyle's law. This is given by Boyle's law. So this is equation 1. That is PV is, okay, P is inversely proportional to V. Now another equation, that is Charles' law. Charles' law. As per Charles' law, what happened? It is saying that we are not increasing our pressure. Pressure is not increasing. So suppose I am giving a heat, and pressure is not changing. So where heat goes away. So what heat will do? Heat will either increase the volume. Heat will either increase the volume of the piston. So that is volume will increase, as well as temperature will increase, because whenever if you apply a heat, so as soon as temperature will increase, so volume will increase. Anyhow, if you are increasing the temperature, so as a result volume will increase, because as the temperature of the gas will increase, so it will try to expand, and due to the expansion, what will happen? Volume will increase. I am just telling you that pressure is constant. See here, if it is your flexible and flexible piston, okay, and it is moving here and there is frictionless piston. So what will happen? If it will try to increase the pressure, it will move or slip in the right direction. So this is what they are telling. So as per the Charles law, volume is directly proportional to temperature, but the thing is that at a constant temperature, and this is known as Charles law. So this is the equation number 2. Now I am talking about Avogadro law. What is Avogadro law? So at a constant pressure and temperature, volume is proportional to number of moles. So see, they told that pressure will remain constant. See here, same piston and cylinder. Pressure will remain constant. Temperature will remain constant. Pressure, temperature, all will remain constant. It means that we are not applying a heat from outside. And if I am not applying a heat from outside and volume is expanding, how volume is being expanded? So suppose number of moles we are pushing. Suppose I have made a hole and I have started filling a gas. So if I will fill a gas, that is number of moles is increasing, right? So if number of moles is increasing, it means that volume is increasing. So this is how this all three equation has been written, right? So how many equations we have? Pressure is inversely proportional to volume. Volume is directly proportional to temperature, and volume is inversely directly proportional to N. So we need to now combine all these three equations. See here, if you will combine this equation, see here, PV, for example, PV proportional to 1, V proportional to T, V proportional to N. So V is common. So can we write here PV proportional to NT, and PV is equal to nRT, where R is the gas constant. Can we write this? So definitely we can write this. So these are the equation. By combining all these three equations, we will get PV is equal to nRT. And this is known as the ideal gas equation. Okay, that is those gas who follows all three laws are known as ideal gas equation. But in reality, you will find so many practical applications that it is a real ideal gas does not exist. But in studying any type of physics, we should take any standard one, and now we need to compare. As you know that any engine does not have an efficiency of 100%, right? But we will always compare efficiency from our practical engine, so that we can try to reach to the ideal condition, try to reach the 100% efficiency at all. So that's why ideal gas has been considered. Okay, so I hope you have understood. There is a lots of application of ideal gas equation. So by using this only, we will go far in a thermodynamics. Okay, so this is how it has been explained. Now let us try to define absolute temperature. Okay, what is absolute? Absolute means purely the lowest temperature of minus 273.16, at which gas is supposed to have zero volume and zero pressure, and which entire molecule motion is supposed to be zero. For example, if you will take any ice also, and it has the minus 1 degree Celsius also, in spite of minus 1 degree Celsius, it is moving up and down. So when we go to a lower as minus 10 degree also, in spite of this, molecular movement are there. But if, so as see here, as you increase the temperature, what will happen? Molecular movement will increase. Okay, and as you decrease the temperature, so molecular movement will decrease. So we have started decreasing the molecular movement by reducing the temperature. So from 0 degree Celsius to minus 10, minus like this went down. Okay, so one point come, or one state is coming where we have seen that molecular movement becomes zero, pressure becomes zero, that is totally vacuum. So at that temperature is known as absolute temperature, and we generally told that absolute temperature is your minus 273.16 degrees Celsius, or you can say 0 Kelvin. Okay, so these are the two basic. You can take either temperature in Celsius or scale, right? So this is known as absolute temperature. This is known as absolute temperature. I hope you have understood now. Okay. Now from figure you can understand that I am trying to make you understand that what is absolute zero temperature. So here see here here we have seen that at 373.15 Kelvin, that is, if you convert it into degree Celsius, so it will be approximately 100 degrees Celsius. So boiling water, so thermal energy is very much greater. So molecule have a velocity and can be evaporated. See here, it has very much high speed. Now as soon as you come down, that is 273.1 Kelvin, that is equal to 0 degrees Celsius. So what is happening? So it is in the form of frozen. So thermal energy is still greater. Okay, thermal energy is still greater here than 0. We can't say that it has 0 thermal energy. You know, because what will happen, see here, let us consider there is an ice and it has a temperature of how much? Minus 1 degree Celsius. How many? Minus 1 degree Celsius. And another ice is there and it has temperature of minus 10 degrees Celsius. So you know that heat will flow from minus 1 degree Celsius to minus 10. So still heat is transferring from high level to low level in spite of being minus 1 degree Celsius. It means that it has some sort of thermal energy at all. So see here, thermal in form of a frozen state also, molecules have no velocity but still can vibrate. See here, in this molecules are vibrating at least. So due to vibration, it has thermal energy at all. Now, if you come to the case of 0 Kelvin or minus 273.16 degrees Celsius, so what is happening? It has zero thermal energy. Absolute zero is the lowest achievable temperature in the universe, and all motion has virtually stopped. So at this, see here, no molecules are vibrating at all. Movement, it is very far, but let us consider if it is vibrating or not. So we can say that this is not vibrating at all, right? So I hope you have understood now. Now we will try to understand the graph. Okay, see here graph. So this is your pressure versus temperature of a low density gas kept at a constant volume. So if gas is there and it has a constant volume at all, volume will remain constant. It is fixed, right? Suppose this is your piston and piston has been fixed, right? So no volume is either decreasing or increasing. Okay, so pressure versus temperature of a low temperature. So here, see here, pressure. As you increase the pressure, so what will happen? Temperature will increase. But as you reduce the pressure, so what will happen? Temperature start falling. So finally, a point will come which is known as absolute zero temperature will come. Now, it does not matter which gas you are taking, either gas A, either gas B, either gas C, all will follow the different path, definitely. But the absolute, as soon as you come for absolute zero temperature, so you will get 0 Kelvin at this point. So plot of a pressure versus temperature and extra pollution of a line for a low density gas indicates the same absolute temperature. So absolute temperature of all gas in the universe will have a zero Kelvin or minus 273 degrees Celsius. Okay, so this is all about absolute temperature. So absolute temperature is fixed. It does not vary with respect to either any different type of gas A, gas B, and gas C. So I hope you have understood. So whatever I have given a topic and I have tried to make you explain very much clearly, and I hope you have enjoyed our video. And if you want more and more video, be connected. Subscribe our channel so that you will get regular updated, because I am coming with a more and more video with numericals and as well as. Okay, so try to be take a continuous class from me. Okay. I hope you understood and enjoyed the session. Thank you for watching my video.